Okay. So आज का point है unipolar encoding. Okay. And a line code. Unipolar is a line code. Okay. Yeah, unipolar is a line code. So we have studied about line coding, right, in previous lecture. A positive voltage represent a binary 1. Positive voltage क्या represent करता है? Binary 1. Okay. A positive voltage is represent a positive volt. Okay. Voltage represent binary 1. Okay. And 0 volts. Okay. And 0 volts is represent 0 volts. Represent, of course, 0. Okay. Binary 0. So here, unipolar is a line code. A positive voltage represent binary 1 and 0 volts indicates a binary 0. It is the simplest line code. Okay, here the unipolar is a line coding. मतलब 0 और 1 का representation होगा. They like 1 positive volts represent the binary 1 and negative volts represent the binary 0. Okay, so it is the simplest line code, directly encoding the bit stream and is analogs to on-off keying in modulation. For this reason, unipolar encoding is not normally used in data communication today. Okay, a unipolar signal is a one that range from 0 to plus full scale, never goes below 0. A bipolar signal is a one that range from some negative value to some positive value, is both positive and negative going. Line code is a code used for data transmission of digital signal over a transmission line. The process of coding is chosen so as the avoid overlap and distortion. Okay, distortion of signals such as inter-symbol system. So here line code is the code used for data transmission. Okay, here line code is used for the data transmission of digital signal over a transmission line. Okay, so this process of coding is a chosen so as to avoid overlap. ये process क्यों choose किए? तो overlap को avoid करने के लिए. Okay. So here the properties of line coding is we can see in this as the coding is done to make more bits transmit on signal single. The bandwidth use is much reduced. For given bandwidth, the power is efficiently used. The probability of error is much reduces, right? So it is the like properties which used to reduce the error probabilities. Okay. Then power density is much variable. Timing content is okay. A long string 1s 0s avoided. Okay, maintain transparency to maintain transparency to avoid the error. Like this is for this purpose properties is there here. Okay, so here types of line coding is there. So here three types of their line coding. First one is the unipolar. Okay, then second is a polar. Okay, and third one is a bipolar. Okay, so let's see one by one unipolar here. So unipolar signaling. So unipolar signaling is also called as on-off keying. Okay, so unipolar signaling is also called as like also called as on-off key. Okay, on-off keying or simply is called on-off keying. Oh, okay. So unipolar is signaling is called as the on-off keying, or simply we can say okay. So the presence of the pulse represent 1 and absence of pulse represent 0. So यहाँ पे जो अगर pulse present होगी तो वो use करेगा 1 indicate 1 and absence होगा तो indicate 0. So you can understand that pulse कहाँ present है और कहाँ absent है with the help of this diagram, right? So there are two voltage in unipolar signaling. That is a non-return zero NRZ and return to zero NRZ. Okay, so non-return and return to zero. Okay, return to zero and non NRZ. That is a non-return zero. So the two क्या है variation है यहाँ पे, two variation, that is the and non-return to zero and return to zero. Okay. So unipolar non-return to zero. Okay. So here you can see that in this type unipolar signaling, a high in the data is represented by positive. Okay, positive pulse called as mark. So in this type of unipolar signaling, a high is data is represented by positive pulse called mark, which has a duration t0 equal to symbol bit duration a. Low in data input has no pulse. So the following figure clearly depicts this. Okay. So here advantages of unipolar, that is it is simple. A laser bandwidth is required. So this is a simple and laser bandwidth is required. It is simple. Okay. So you can see this. So here it is a simple so a laser bandwidth is required. Then disadvantages is that the disorder of unipolar NRZ are no error correction. Presence of low frequency component may cause the signal drop. No clock is present, so loss of synchronization is likely to occur first 0 and 1. So unipolar energy, in this format we can say that logic 1 is represented by pulse of full bit duration TB and amplitude plus A. Okay, see this. Okay, so during the on time the pulse does not return to zero. During the on time the pulse does not return to the zero. Okay, so here you can say that NRJ format as the pulse have either plus A or zero amplitude. It is called the unipolar format. Means pulse have either plus A, means having number, otherwise zero. That is called the unipolar. Internal computer waveform are usually of this type due to the unipolar nature. The unipolar NRJ format also will be non-zero average. Okay, so the disadvantage of two unipolar format discussed earlier that they result in DC component that does not carry any information and waste power. So the polar RJ format is shown. We can see we have seen the polar RJ format. This is a polar RJ format, right? So it is a polar format as pulse return to the zero. Here pulse is returned to the zero after half the beat duration. Okay, it's returned to the zero after half a beat duration. Okay, so here unipolar advantage is a simple. It is a simple. The spectral line present at the symbol rate can be used. Okay, see here advantages. Okay, so disadvantage is no error correction. Then occupies twice the bandwidth has unipolar NRJ. So polar signaling. So polar NRZ and polar RZ. So polar NRZ and polar RZ. So in this type polar signaling, high in data is represented by positive pulse, while low is data is represented by negative pulse. The following figure is showing here is a positive pulse. High data represent by pulse, means positive pulse, and low data is represent negative pulse. Okay, so here in this energy polar, we can see in this figure that what duration means positive and negative. We said that, so unlike the unipolar waveform, is a polar wave has no DC component. Okay, for this purpose, this is the diagram of polar Z. So here in this format, symbol 1 is represented by transmitting positive pulse the of A. plus a by 2 and amplitude for 1/2 of the symbol duration, followed by negative pulse amplitude that is minus a2. मतलब यहाँ पे अगर positive pulse होगा so it will be look like this. 1 minute. Like plus a by 2, and it is, if it's negative, then minus a by 2. So here in this format, 1 is represented by transmission positive pulse. 1 is represented by transmitted positive pulse, that is positive. And okay, so here 1 is represented by transmitted positive pulse of a by 2 pulse plus a by 2 amplitude for 1/2 of the symbol duration, followed by the negative pulse as the amplitude minus a by 2 for remaining half of symbol duration. For symbol 0, these two pulses are transmitted in reverse order. This waveform does not have any DC component. The you can say the format has the built synchronization capability as it cross 0 at regular interval, but this capability is attained at the expense of bandwidth required of twice that of the energy unipolar, polar, and bipolar format. So okay, so bipolar signaling. So this is a diagram of bipolar signaling here. And this is an encoding technique. Okay, this is an encoding technique which has 3 voltage level, namely. So this is the encoding technique. Okay, okay. So here encoding technique which has 3 voltage level, namely plus, minus, and 0. Okay, so this is encoding technique having the 3 voltage, that is namely plus, minus, and 0. Such a signal is called as dual binary signal. So this signal is called as dual binary signal. An example of this type of alternate mask inversion is the MIA. MIA for a 1, the voltage level gets transmission from plus to 0 or 0 to having a alternate 1s to be equal. Okay, a is 0 will be 0 voltage level. Even this method we have two type, bipolar analysis and polar analysis. So here this is a diagram. From the models of so far discussed, we have learned the difference between NRJ and RJ. It just goes in the same way. Here too the following figures is clearly described. This is the figure has both bipolar energy to RJ waveform. The pulse duration and symbol bit duration are equal in RJ. Pulse duration and symbol duration are equal in RJ type, while the pulse duration is half of the symbol bit duration in RJ type. Okay. The okay, so we said that difference between RZ and NRZ is what? A return to 0, that is a signal transmission of logical 1 will always being at 0 and end at 0, whereas NRJ is a non-return 0. RJ is a return 0. There here signal transmission of logic 1 will always be at 0, and here whereas NRJ is non-return to 0, signal transmission of logic 1 may or may not be being at the 0 and end 0. Okay, so this is the difference of NRJ and RJ. So The NRJ is written to zero. Signal transmission logic 1 will always being at zero and end at zero, whereas NRJ and non-written zero is signal transmission of logic 1 may or may not be at the zero and end at the zero. So okay, this is a diagram. Okay, the here this figure has both the bipolar NRJ and RJ waveform, the pulse duration and symbol beat. Okay, so the pulse duration and symbol B duration are equal in NRJ type, while the pulse duration is half of the symbol duration in RJ type. So this is the advantages. So let's see the advantages. So here the advantages of following, that is it is a simple, no low frequency component are present. Okay, low frequency component are not present, occupies low bandwidth than unipolar and polar energy scheme. This technique is suitable for transmission over AC couple lines, as signal dropping does not occur here. A signal error detection capability is present in this. So disadvantages is that, so advantages is what the error detection capability is present. If error is there, then it will be represent the error. This is the capability is present here. So no low frequency component are present. So frequency component is not low frequency component are present, and it is a simple. So this technique is a suitable of transmission over AC couple lines, as the signal dropping does not occur here. So disadvantages that is following are the disadvantages that no clock is present. Long string of data cause loss of synchronization. Okay, so analog to digital conversion. So here what they do. So analog to digital conversion, what they do. Analog to digital conversion, translate analog signal. We know analog means what, digital means what. Analog data we have studied, that digital data also we have studied. So analog to digital conversion here, translate analog signal, real world signal like temperature, pressure, voltage, current, distance, or light intensity into digital representation of the that signal. This digital representation can then be proceed, manipulated, computer, transmitted, or stored. So analog to digital converts, translate the analog signals. Real world is signals like what? It's like a temperature, pressure, voltage, current, distance, or light intensity, right? In many cases, the analog to digital conversion axis is just one step within a large measure, right? So this transition can include things like motor, heaters. So in many cases, the analog to digital conversion process is just one step within a larger measurement and control loop where digitalized data is proceed and then reconvert back to analog signal to the derived external transistor. These transistors can include things like motor, heaters, and we can say the loudspeaker. The performance of requirement on the ADC will reflect the performance goal of the measurement and control loop. ADC performance need will be also reflected the capability and requirement of the other signal process elements in the loop. So this is a diagram of analog measurement and control loop. Okay. So here what we said, that measurement and control loop in these, the ADC will reflect the performance goal of the measurement and control loop. So ADC performance need will also reflect the capability and requirement of the other signal processing element is the loop. Okay, in the loop, sorry. So here the basic operation are there for, so the ADC samples as analog waveform at uniform time intervals and assigning a digital value to each sample. The digital value appears on the convert output. So here, so what is the basic operation? This is the diagram of the basic operation here. So this is the basic ADC's basic operation. On ADC, sample as an analog waveform at uniform time intervals and assign a digital value to each sample. The digital value appears on the convert outputs in binary coded format. The value is obtained by dividing the sample analog input voltage by the reference voltage, and they multiply by number of digital codes. The resolution of the convert is set by the number of binary bits in the output code. So digital output code, this is the diagram. Okay. So here an ADC carrier out to process sampling and quantization. So sampling and quantization की दो process है. The ADC represent an analog signal which has infinite resolution, as digital code that has finite resolution. So ADC represent an analog signal which has infinite resolution and finite, and digital having finite resolution. The ADC produce 2n digital value where and represent the number of binary output bits. The analog input signal will fall between the quantization level because the converts has finite resolution, resulting in a internet. So uncertainty or quantization error. That error determines the maximum dynamic range of the converter. Quantization processor, sampling processor. This is a diagram of the quantization processor. This is the diagram of the sampling processor. Sampling processor, this is okay. So sampling processor represent continue time domain signal. Sampling processor represent the continue time domain signal with value measured at the discrete and uniform time intervals. So this process determine the maximum bandwidth. So this process determine the maximum bandwidth of the sample signal in accordance with the theory. This theory states that the signal frequency must be less than or equal to one half the sampling frequency to prevent the aliasing is a coordination with which frequency signal outside the desired signal band will through the sampling process appears can be explained in communication system designed to down convert a high frequency signal to low frequency. So this technique is known as the undersampling. Certain for undersampling is that ADC has sufficient input bandwidth and dynamic range to require the highest frequency signal on of the internet. So sampling and quantization are important concepts because they establish the performance limit of the idea ADC. So this is the important concept because it is establish the performance limits of the an idea ADC. In idea ADC, the core transmission are exactly one list signature B. Okay, LCB at least signature B. Apart so for an n bit ADC, there are two n codes and LSB that is a least significant bit is equal to FS means here. So here least significant bit is equal to frequency sampling upon 2n. Okay. So here, whereas Fs is the full scale analog, Fs is a full scale analog input voltage. However, ADC operation in the real world is also affected by non-ideal affected, which produce error beyond those directed by converter resolution and sample rate. There, these errors are reflected in the number of AC and DC performance specification association with ADC. So any analog input is a range gives as the name digital code. So what is the exactly PCM? Pulse code modulation. PCM is a pulse code modulation is a method used to digitalize represent sample analog signal. So ये एक मेथड है जो कि एनालॉग सिग्नल के सैंपल को रिप्रेजेंट करने के लिए स्टेबलाइज हुई है या इनिशियलाइज है. So it is a standard form for digital audio and computer and various component. So DVD format as well as other uses such as digital telephone system. A PCM system is a digital representation of an analog signal in which the magnitude of the analog signal is a sample regularly at the uniform intervals, with each sample being quantization to the nearest value within a range of digital state. So basics of a pulse code modulation, that is a PCM, here are three steps developing the unequivalent PCM digital signal from an analog signal. The typical human speech is represented by simple 12 hertz tone. Means a typical human की speech किसे represent करती है 1200 that is a 1200, okay, which is represented by the sine wave. So the three types, that is sampling, quantization, and coding. So sampling, if a fine signal is at regular intervals of the time at rate equal to higher. So here three types is there: sampling, quantization, and coding. So sampling rate determines the spatial resolution of the digitized image, while the quantization level determines the number of gray level. Sampling determines the spatial resolution of digitalized image. So it is determined the digitalized image, while the quantization level determines the number of gray level. In the digital image, a magnitude of sample image is expressed as digital value in image processing. Okay, so quantization is show the like gray type image. Okay, so the sampling are determine the spatial resolution, right? So a magnitude of the sample image is expressed as a digital value in image processing. So you will be see this sampling and quantization in detail in TYCS, in DIP digital image processing. You will be see this in detail. Particular chapter is there on sampling and quantization. Just understand here only कि gray image and it is a indicate for to digitalized image. Okay, to show the image through the this information means sampling. So here we can say the sample contains all information of original signal. The original signal may then be reconstructed by use to low pass filter. So low pass filter, high pass filter, this all will be in DIP, that is the digital image processing subject, which will be you will see in TYCA. Okay, so quantization here. The purpose of PCM system is to transmit to the distance and the volume of voltage sample at the certain moment in time. The next step is to assign a binary sequence to each of those voltage sample. This step is called quantization. For discussion sake, we assume the maximum that PM within 1 voltage to -1 voltage, मतलब ये between arise होती है plus positive voltage to negative voltage. We are looking in binary domain. We select the total number of discrete value to be binary number multiply, that is 2, 4, 8, 16, 32, 64, 128, and so on. They facilitate binary coding. For instance, if there were 4 values, they will be follow like 0, 0, 0, 1, 1, 0, 1, 1. This is 2-bit code, right? Then coding. Older PCM system use 7-bit code and modern system use 8-bit code. Improve the quantization distortion performance. The compounding and coding are carried out together simultaneously. The compression and later expansion function are logarithm. A pseudo algorithm cover made up the linear segment impart finer grant to low level. Okay, so coding here. So in short, we can say the coding, the process for converting the line coding. This is a coding here given in this what PCM having the types, that sampling, quantization, coding. So the coding is the process for, you can say that the coding The process for converting digital data into digital signal is said to be line code. Or digital data is found in binary format. It is a represents like ones and zeros. So coding is the process for converting digital data into means digital data into digital signals. So with the help of coding, we can save means we can send digital data into digital signal. Digital signal is denoted by discrete signal which is not continuous, which is represent digital data. There are three types of line coding system available, like unipolar, polar, and bipolar, which we have seen. Unipolar means, encoding scheme use signal voltage level represent data. In this case, to represent binary one, high voltage is transmitted and zero represent zero. No voltage is transmitted. It is also called unipolar return to zero, right? We have studied. And polar is a encoding scheme uses multiple voltage level to represent binary voltage. Polar encoding is available four types, so it is used to different voltage level. Okay, then return to zero, and we have say energy means what? Return to zero is a problem with return to zero, or energy is that the receiver cannot conclude when bit ended and when a next bit is started, in case when sender and receiver's clock are not synchronized. So return to zero में sender और receiver को confirm नहीं होगा when they will receive and transmit, because अगर clock is synchronized नहीं हुई तो. Okay, so this is about the bipolar. We have studied about bipolar, right? So here bipolar is there. Okay, so the to show bipolar here, the encoding uses three voltage level, positive, negative, and zero, which we have seen, right? Then, so okay, so today's lecture over here. Thank you.